Hello, welcome back. Today we are discussing about programming exercise in milling. Our raw material is a rectangular piece of material and its dimensions are given as 100 into 100, that is the length is 100 mm, width is 100 mm and the depth is 10 millimeter. And from that, out of that size, we need to make a shape like this, and which will have a depth of 4 mm. So it will be like this. It will be projecting from the surface of the workpiece. All required dimensions of the shape required is given. It contains two curved surfaces also, which is having a radius of R20, another having a radius of R18. And in milling, we are following the FANUC control system. Let's start with the main program. The main program number in FANUC is represented with a percentage symbol, and the number is given as 1000. So that is the identification of this program. Then the second line consists of, otherwise second block consists of G21 and G94, already discussed. G21 is for mm per metric input, and G94 is the mm per revolution, mm per minute. That is feed rate. And next is the G91, that is new to this one, that is in FANUC. Whenever we are giving the G28 code, and that is means the tool has to move to its home position, otherwise we have to ensure that the tool is in the home position. So whenever this G28 is given, we have to give the G91, and G91 stands for incremental dimensioning. So only for G28 we are using G91, that is the incremental dimensioning, and all other work is performed in absolute dimension system. In absolute dimension, we are again using G90. So whenever we need absolute dimension, we have to use G91. Otherwise, in a tool home position, we have to use the G91 code. Then next is G28. So again, we are using the G28 to ensure that the tool is in X0 and Y0 position. If we are using this G91 along with the G28, the machine understood that this Z0, X0 and Y0 are actually referring the tool home position. The next is M06, that is a tool selection. So we are selecting the tool number 1, which is having offsets at D01. So D01 is an address in which we are showing the or storing the offsets of the tool. In a milling machine, we have got two offsets. That is, one radius offset is there, that is a radius compensation is given. Then another offset is the length offset or length compensation. Then next is S is the spindle speed, so 1000 RPM we will set on the spindle, and the spindle is rotated using M03. M03 is used for counterclockwise rotation. Then actually we are going to move the tool. So here we are using G90 because now we need absolute dimension system. Then G00 is given. Then we are then G41 is used for giving the cutter radius compensation to the left, because we wanted to move the tool along this side in this direction. So this is actually, the tool is on the left side of the workpiece. So G41 is used to give that cutter radius compensation, and then that is G41. Then initial position is given as X20, Y20 and Z5. So X20, Y20, Z5 means X20, Y20 is this portion, and Z5 means the tool has to reach 5 millimeter above the workpiece. So the tool will be that is 5 millimeter will be this one. So if it is will be 5 millimeter, the tool has to come at this level. Okay, then since we have given the offset, so the tool is not coming exactly to this point, it is actually offsetted from that point, and it will be coming somewhere here. The tool will be coming somewhere here. We are not mentioning the diameter of the tool. Most probably we are using an end mill, and it will be coming like this. Okay. Since we have given this G41 here, the tool has to be offsetted from both the x-axis position and y-axis position like this, and now the tool has to move in this direction. So whatever may be the tool radius, it has to be offsetted from both x-axis and y-axis. The actual position for x20, y20 will be here only, and this is our work 0 point. Okay, so this is our actually initially we are defining this position as the work 0 point. So from this work 0 point, this is the x20 and y20. But since we have used this G41, the tool has been offsetted this much distance, that is r from the y-axis, and similarly r from the required position in the x-axis. So that's why initially the tool will be in this position by calling, and it will be above 5 millimeter from the surface of the workpiece, since we have given this z is equal to 5. In next block, we have to give a just a touch of the tool tip with the work surface. So for that we are using G01, and the tool is moved to Z0. That means the tool is lowered. From that position, the tool is just lowered. It is just touching the surface of the workpiece, since it is Z0, and the feed rate is given as 50 mm per revolution. The next block is started with a code M98, and that is for calling a subprogram in FANUC. And the subprogram is actually it is represented with the P008 4000, and P008 means it has to be called for 8 times. Okay, the same subprogram has to be called 8 times, and the subprogram number is given as 4000. So the idea is that by calling this subprogram of 4000 for 8 times means we can finish our work. So after finishing the work, so that we will discuss what is the subprogram and how it is writing. That will be discussed later. And after doing the work, so after executing the subprogram, we are assuming that our work is finished. Now after that, the next block is we have to retrieve the or retract the tool from the work surface. So it in G00 Z5 means what is the end position. So from the end position, it has to be moved again Z5. So it has to be maintained this position again 5 mm above the workpiece surface. Then G91. So 91 is again we are using for incremental positioning. And then we needed to move the tool to its home position. G28, X0, Z0, X0, and Y0. Then M05 is used for stopping the spindle. Then finally M30 is reached. That means the end of the program. Next step is writing the subprogram. The subprogram number is given as 4000. So it is represented in the program as %4000. Then the first block is again another subprogram that we are neglecting for the time being. That will be discussed later. So the first step is G01. G01 stands for the linear interpolation. So linear interpolation, we need to move the tool in a linear direction. So assume that the tool is in the first location before starting the subprogram. So in the subprogram, we have to move the tool to the position number 2, and the position number 2 coordinates are given, that is 20 and 80. So X20, Y80, and the feed rate is 50 mm per revolution, mm per minute. And then the next is we need to move the tool to the third position. So the third position coordinates are 60 and 80. Only change is in x-axis, x direction. So it is only x is given. So 80 is the same thing. Y-axis there is no change. And next is we have to perform a curved path. The tool has to move in a curved path, that is in counterclockwise direction. So that's the endpoints are 80 and 60, and so G03 is given for the circular interpolation in counterclockwise direction, and the endpoints are 80 and 60 is given, and the radius is given as 20. The feed rate is the very same. If change in feed rate is required, that we have to give it separately. Then again we have to perform a linear interpolation, and the tool has to reach at a point where y is equal to 38. There is no change in the x direction. And then we have to perform another curved movement, that is the circular interpolation in clockwise direction. And that is the endpoints are given in the point number 6, and it is actually 62 and 20. So x and y we are giving 62 and 20, and again here also we have to mention the radius are 80. Then next again we have to perform the linear interpolation to reach the initial point. So again we have to give the x-axis only, because y-axis is 20 itself, there is no change, and x2 20, and finally M99 is used, that is giving the end of the subprogram. Now the command has to be returned to the main program. So in the subprogram 4000 we have given all the tool positions. All the tool path is defined, but it does not have any tool depth command. So in order to give the depth of the tool, we are using another subprogram, a numpad 4001. Now next step is we have to write the subprogram 4001. So in this subprogram 4001, we need to only give the depth of the each cut, because we can't do the whole 4 mm depth of cut in a single pass. Assume that our machine is that not that much strong, so the each and every time we are selecting an increase in depth of 0.5 mm. So that's why it required 8 passes, that is given in the first subprogram. So 8 times we have to call the subprogram. But here first the block is started with G91. G91 stands for incremental dimensioning. So each and every time we are increasing 0.5, 0.5 like that. So that's why we are using the incremental method over here. So G91 is used, then G01 for linear interpolation. So the depth is increased to 0.5. Then the feed is also selected, and after that we have to change it to absolute incremental system. Then we have to exit from this subprogram. It will be moved back to the subprogram 1 here. After increasing the 0.5 mm depth, we have to move the tool to all the position locations. All the tool path is now covered, and after that this M99, the tool has to be the command has to be moved back to this position, because here it is already written that we have to perform this subprogram number 1 8 times. So again it will be performing the same thing at 8 times, and each time it is coming to the subprogram 2, and whenever it is coming to subprogram 2, in all time the depth will be increased by 0.5 mm. So 0.5, 0.5, 8 times it is moving means totally we will get 4 mm depth of cut. So after 8 times of this performing this subprogram, our work will be finished. So here it shows the completed program. Here it is R18. Thank you for watching.